storing all the data in the world it's really important. It's a really big deal. Just think about what would happen if suddenly all that data disappeared. All of the slide presentations, email, Twitter feeds, celebrity pictures, cat videos, financial records, cancer research, it would just stop. So that's obviously something that's really essential to our commerce, our culture. It's something we touch practically every second of every day. But there's a big challenge in storing that information. And that challenge is that every second of every day, we set a new world record in how much we store. It's constantly growing. And the reason why data is constantly growing is really because technology is constantly getting better. And the benefits of new technology are undeniable. Every time you turn around and buy a new phone, it's got all kinds of new features. It's got more megapixels in the camera. You go to the doctor, you get a higher resolution CAT scan, they can better diagnose what's wrong, and on and on. But all these new technologies have one thing in common. They all make more data, a lot more data. If you look at the size of a picture in terms of how much storage it required 10 years ago versus 5 years ago versus now, it keeps getting bigger. And there's no end in sight because technology will just keep getting better and better. In general, this rate of growth is equivalent to about 100 times more data every 10 years. When we looked at this problem several years ago, we recognized, however, that even though there was this insatiable demand, and this was really, really important, the way the world was storing its data, the growing data that we're creating, was about to fail. And the reason why that was going to happen is because the way that data storage was working was based on a method that was invented for the telephone network many, many decades ago. And it needed to change. If you go back and look at how the telephone network worked, it was a method that basically connected a wire between the sender and the receiver when you made a call. That's what a switchboard was. And I know today, for many of you, telephone is just an application that you never use. But it used to be really important. We used to call each other, and that was really the only way you could talk. I mean, you couldn't text, you couldn't email, there was no Facebook. People really relied on phone calls for everything, social interaction, commerce, in the way that we rely on data storage today. And that method that was created for the telephone network was one where when a call would be placed, a wire would literally be connected between the caller and the receiver. And as they would talk back and forth, information would flow in real time down that wire, back and forth, as they would talk back and forth to each other. It was what's called a circuit. There was no virtualization of the circuit. There was no virtualization of the information. And that's the best method to create one connection in a network. But it's a method that gets a little bit less efficient as you create more connections in the network. When you have 1,000, you're still good. When you have 1,000,000, you're okay. When you have 1,000,000,000, you really run out of steam. And this was a system that didn't scale and was ultimately replaced. And the way that data storage has been working is using this same method, basically. Data is always just some string of numbers, and something that creates data could be a camera, for example. So when you take a picture, as someone's doing right now, what's going to happen is that CCD chip inside that phone is going to create a string of numbers that's going to represent the pixels, the colors in the picture. And those are just going to get written down into the media, the flash chip on that phone. That's what's happened just a second ago. So that's a method that works a lot like the telephone network. In the same way that the telephone network took information, just sent it down a wire, sent it out the other side, what just happened on that phone is information came out of that camera and went into the storage in linear order. And then at some point in the future, to look at that picture, it'll just get read right back out in linear order. So in a lot of ways, it works like the telephony network in that the way it stores information. But it has a problem, that method. In the same way that the telephony network didn't scale and was eventually replaced, storing data in that way doesn't scale to forever and is being replaced today. One of the things that comes from that method of not virtualizing the data is that it gets harder and harder as it gets bigger and bigger, the whole system. So back when we had to store a small amount of data 50 years ago, that method of making actual copies on media was perfect. But like the telephone network, it got worse as it grew. And one reason it gets worse is because as you store more and more data, in order to maintain a given level of reliability, a high level of reliability, you have to make more and more copies. So what's happening is data is getting bigger and bigger, and you're having to make more and more copies to keep it reliable, and at some point you have to change. You just can't keep accelerating at that rate. So what we looked at is maybe we could solve that problem by looking at the solution that solved the problem for telephony. Ultimately, telephony has been replaced by a different method, which is the way the internet works and the way that wireless communications and all your phones work. And that combination of the internet and mobile communications has become the world's new communications network. That's how we communicate today. And that system handles billions and billions of connections every second of every day. And a big change that occurred is instead of having a wire that moves from point A to point B, you can't have a billion wires. Instead, what the internet does is it virtualizes the information and it virtualizes the connection. It looks like something's moving from a web server to your phone, but that's not what physically happens. What happens is that web pages are broken into a lot of little pieces. Those pieces are routed independently around the network with all the other things that are moving through the network at that time. And then they arrive, all those different pieces, sometimes at different times at your phone, and they're all put back together, and now it looks like a picture just came from a website. But it all happened so fast, it looks like it moved from point A to point B. That method has one big advantage over telephony, is that that's a very inefficient way to move something from one person to another, but it's a method that gets more efficient as you have more connections in the network. And therefore, eventually, telephony was getting less efficient. Packet switching, which is what this is called, what the internet uses, is getting more efficient. At some point, it crossed over about 20 years ago, and we just switched over to using packet switching. And then the other technique that we've layered on top of that is wireless communications. Wireless is incredible technology. When we sit here in this room and you guys have a break, and we all light up our phones and check our messages and look at pictures and all that stuff, what's really happening in this space is all this little spectrum that our phones are using are all sending out all these messages, literally millions of these messages, and they're all colliding with each other because we're all in the same room, and not all those little packets get through. But the way the information is encoded, the way the radio makes all those little pulses of information, it's made in such a way that they don't all have to get through, and then you can create a situation where statistically enough of them will get through so that it'll look to all of us like all of our phones are working. And that's what happens every time we sit here and check everything going on in the rest of the world. So that's, in combination, wireless and internet, that's really how the world communicates. So the question we asked ourselves when we looked at this problem of storage, how could we solve the problem of increasing demand, increasing amount, increasing importance of digital information? We could solve that by using the same method that the internet and wireless uses. So in the same way that those techniques replaced telephony for communications, we thought, well, maybe we could use those techniques to replace making literal copies of information to store all the information in the world. And what we set out to do was to build a system that had those same properties, that the more you stored, the better the system got. The more reliable it got, the more cost efficient it got, the more performant it got. And that turned out to be successful. So I started a company a little over 11 years ago that did this, that we kind of challenged the conventional thinking that the way to store information is to make copies, and instead build a technology that kind of rethought the whole question from the very beginning, and it turned out to be successful. Today, just about every one of you are going to use this technology multiple times today. When you look at a picture, when you make a video, when you watch television, if you were to go to the doctor, information that's created about you based on transactions, commerce that you conduct today, maps that you look at, things like that. All those big data storing applications, more and more of those behind the scenes are using technology from a company called Cleversafe that I started. So that stepping back and really thinking the problem from the very beginning turned out to be quite successful. It was not just something that I thought up and was done. What we had to do to pull this off was it took about 100 people and about $100 million over 10 years. And we had not one idea, but we ended up having over 1,000 ideas. And that was ultimately what made that all work. So for me, the question was not, how could I come up with an idea? The real question was, how could I create a team of people that could come up with 1,000 ideas? And that's really the key to success in a lot of these kind of problems where it's well beyond the scope of any one person or any 10 people. The real question is, how do you build a team that has the characteristics to take on and solve a problem like this? And what I found in that experience is that it ultimately came down to a few things. One, you want to have a vision that typically is a big vision. And our vision from the very beginning was, well, let's build the technology to store all the data in the world. That's a pretty big vision. Second thing is, we needed a team of incredibly capable people. And we were able to create that, partly because there was the type of person that wanted to work on that kind of a vision. We were actually located here at Illinois Tech for 3 years upstairs on the 16th floor when we were building that team. And that's been a real success for us. And then finally, we had to have a culture that fit that vision. If you're going to build the technology to store all the data in the world, it defines certain characteristics of how you go about it. You want to be trustworthy. You want to be very capable. It's got to be, extremely high quality work. And so that kind of defined our culture and how we went about it. So I thought about, how did I really learn to do that? And that kind of took me back to an experience that I had when I was in high school. And in some ways, it's similar to the experience that we're having today with this event itself. You've got a lot of folks, as you're seeing every minute, as a part of putting this on. So it's an event that's kind of outside the normal classroom experience, but nonetheless is important learning. For me, that experience that I thought really informed learning how to build teams was an experience I had in high school that was also outside of class. I went to a great high school. We had great classes. I learned a lot, but I also learned a lot of experiences outside of class. And in particular, a very unexpected thing that I was a part of was a big learning experience for me. And that was when I went to high school in my senior year, there was this enormous high school prank that I was a part of. And I learned a lot from that. So I'll tell you first what we did, and then I'll tell you how we did it. So one morning, on a Monday morning, it was actually in March of 1982, and there were still a couple months left in the school year. When everyone got to school that morning, in the school, in the place where all the hallways came together, where everyone had to walk through basically to get from one class to another, sitting there was an enormous tree trunk. It was so big that it was bigger than a door. I mean, it's not like it could just appear there. Like something like the school had to have been taken apart and put back together in order for this to be where it was. It was so heavy that you couldn't roll it, let alone lift it. This thing it weighed around 8,000 to 9,000 pounds. And in particular, the other challenge was it wasn't just downstairs on the ground floor where all the hallways came together. It was on the second floor where all the hallways came together. So much speculation of how did this thing get here. Now, it was obvious that it was a high school prank because on this massive tree trunk, painted along the edge of it was class of 82. That was the senior class. So people knew this was a senior prank. So that's what we pulled off. This is the team that did that in my garage. And you can see this is the night of, and we're all excited, getting ready to go. And so one of the big innovations we had, first we had a big vision. And the big vision was, let's do something that people are going to remember, that maybe in a TED Talk 30 years from now, someone will talk about this. All right, and I texted as I was sitting back here waiting, my friends that did, I'm about to go on. Like these guys in this picture. So we wanted to do something that was really fun and something that we would remember. So we had a big vision. We actually started working on it a year before. So the first idea was, well, maybe if we found a hollow tree, it would be lighter and we could carry that. So we found an enormous hollow tree, and that tree trunk weighed about 2,000 pounds hollow. The second innovation we had was, well, we're going to have to take apart part of the school and put it back together in about 37 minutes in order to pull this off, because it was going to be late in the middle of the night on a Sunday night and we didn't have a lot of time. So we recruited people on the team that had done building construction that could take apart part of the building and put it back together. The next innovation we had was, all right, well, once we get this hollow tree up there on the second floor, let's fill it with cement. Because once we fill it with cement, it'll be not 2,000 pounds, it'll be like 9,000 pounds. And so we had people on the team that had done work with cement, and one of the innovations they came up with was, we knew we had to get water, actually warm water, to mix the cement. So they built an adapter that they could like hook onto the nearest faucet, which happened to be in a girl's bathroom nearby, and then run water to this hollow tree. We built a little like trap door you could open up, put the cement in there, mix it up, close it, and off we went. So those were some of the innovations we had. And we had the satisfaction then for the entire rest of our school year, like every class started about 2 minutes late. And we would just sit there, like all smug, try not, no one knew it was us. But we got to enjoy the satisfaction of knowing we had pulled this off. No one knew, and yet it had this kind of disruption. So part of that was, the vision of doing it, the team that we put together with a diverse set of talents. And then we had a culture that really fit what we did. It was pretty obvious once we got in there that we could have done something destructive, doing what we did, required a lot of equipment and planning, but we wanted to do something that was, clever and not destructive. And I'll tell you one final element of that is when we put the school back together, we had some extra parts, like all the doors worked and everything. So we put all those parts in a box and we drove it over to our principal's house. It's like 4 a.m. and we set it on there with a note, like, "Dear Principal Shelby, when you get to school tomorrow morning, you're going to know where these came from. Just in case you need these, here's all the extra parts. Sincerely, some concerned seniors." So what I learned in that experience was, what really informed the work we did at Cleversafe. If you have a big vision, you get the right team, and then you have the right kind of culture of doing it right, incredible things will happen. Thank you.